So far in this final exam, we've written a lexer, a parser, and now in this problem, we're going to write an interpreter. However, we're mixing it up a bit, and we're not going to write an interpreter for a programming language per se, but rather for a market. We're going to be given a list of how much money people have, things they want to buy, and things they're willing to sell, and we're going to simulate the market, and the result is going to be the amount of money that people have left over. So let's take a look at an example input into our interpreter. So here I have our abstract syntax tree for our market. At the beginning, we declare how much money Claus and Andreas, our two participants in the marketplace, have. And then we talk about what are they willing to buy and sell. Within each element, we generally say who is the person that this element applies to, the what this element is dealing with, and then some amount of money. So for the has elements, we're saying Claus has 100 coins. And we're saying Andreas has 50 coins. Down here, we're saying Claus wants to buy a sheep for 50. He also wants to buy another sheep for 50. You can have more than one. Andreas wants to sell a sheep for 50, and he wants to sell another sheep for 50. So Claus wants to buy 2 sheep, each for 50. Andreas wants to sell 2 sheep, each for 50. We should probably be able to make a deal here. Note that after the has elements, the buys and sells can be in any order. So let's step through this by hand and see if we can come up with an algorithm for which to write our interpreter. So here we're saying Claus has 100 coins. We should probably keep track of that since the output of the entire interpretation is going to be a list of how much money each person has. Or actually we're going to store it as a dictionary, so let's do that. I just wrote Claus for short. Okay, so we say Claus has 100. We are done with this. We don't need it anymore. This next line says Andreas has 50. So let's update our dictionary. All right, we're done with this. Now that we see Claus wants to buy a sheep for 50, let's see if anyone is willing to sell a sheep. So let's go through the rest of them one by one. So in this next line, it's about Claus buying. We don't really care about buying. We're looking for selling. Okay, here we have a sell. It happens to be for a sheep. It also happens to be for the exact amount that we want. So these 3 elements match perfectly for what we're looking for. One more thing that we have to check is to make sure that Claus has at least 50 coins to make the transaction. So we look up here, Claus has 100, that's more than 50, he's able to afford it. So now we do the transaction. Claus now only has 50, and Andreas now has 100. We should cross off the elements that we used, and now let's continue the process from the top again. So we only have 2 things left. So the next one is Claus wants to buy a sheep for 50. We do the same lookup, go to the next element, see sell sheep 50. Yay! Claus has at least 50. We're all good. Let's make the transaction. Okay, we've gone through everything in our parse tree. There's nothing left to do because there's nothing left. So our output is just going to be this dictionary. So we went through that algorithm. It's pretty straightforward. It's a matter of just stepping through what is available and doing what we can until there's nothing left. So now you're probably thinking, where's the code? Well, let me show you. So here I have the solution. It may look a bit messy, but it's actually pretty straightforward. The first thing we do is declare the dictionary that we store how much money each person has. And the basic strategy, like I went over, is to continue going through elements in the parse tree until there's nothing left to do, until we didn't do anything, so nothing's changed, and we should just stop. In the case of the example that I went over, that just meant that we were out of elements. But it could also be the case that no one can afford to buy anything, so we should just stop. So let's assume that there's nothing left to do, and then only change it once we do something. We're going to go through each element in our abstract syntax tree. We're going to pull out who is involved in the element. That's always the 0 index, the first element in the tuple. We're going to do what kind of type it is, and if it's a has. So those are going to go first. We're going to put that person in our environment. And then what I'm doing right here is we're just marking off it as skip. We're changing the type to skip. Skip isn't has, buy, or sell, so we're just going to ignore it. This is equivalent to me crossing it off. An alternative way of doing a similar process would be to recursing onto the parse tree and removing parse tree elements as we use them. But this is just as easy. If we're in a buy scenario, if we find an element for which we want to buy, we're going to take out what we want to buy and how much it's for. And then we're going to go through the abstract syntax tree again. If we find an element in the abstract syntax tree that is a cell, it's what we're looking for, I can afford it for that price, and it's the price that I want to pay for it, we're going to do the transaction. This involves skipping, crossing off both elements in the parse tree that are involved in the transaction, subtracting off the new cost, and adding that amount of money to the person that sold it. And we're also here, we're putting finished equals false because we did something. The state has changed, and we should do another pass. And once we're done, we just return the dictionary that we started with.